Imagine waking up one morning to the headline, Earth discovered as a possible alien interstellar visitor. For centuries, we've stared into space, wondering if anyone's out there. Now, imagine the roles reversed. What if Earth becomes their mysterious object of study? Like 3IATLAS, a real interstellar object that zipped through our solar system, Earth would suddenly be the cosmic guest star. Except this time, we're the ones being observed. Somewhere out there, alien astronomers might be scratching their tentacles wondering who left this noisy, oxygen-leaking planet drifting into our neighborhood. Picture the scene, a distant civilization, peering through their version of telescopes. Maybe biological, maybe mechanical, maybe some kind of psychic jellyfish floating in gas clouds. One of them notices a faint blue dot crossing the dark between stars. It's moving fast, faster than anything bound to their own system, glowing faintly from residual heat. To them, it's just another object cataloged as interstellar anomaly number whatever. But soon, the data starts getting weird. The spectrum reveals oxygen and nitrogen in perfect balance, traces of methane, and a whisper of carbon dioxide. Their scientists would frown. Planets don't just make oxygen on their own unless something's been breathing on them. And that's when Earth stops being just another space rock. It becomes a cosmic puzzle piece that doesn't quite fit. Good evening, curious minds. Science doesn't need to shout to be fascinating. Sometimes, it's best enjoyed the way you'd enjoy a late-night conversation. Quietly, with a cup of tea, and maybe the soft hum of a fan in the background. Before we begin, leave a comment and tell me where and when you're tuning in. And if you find yourself learning something new as you drift towards sleep, consider subscribing. No pressure. Only if you enjoy these calm journeys through the universe. Now, let's begin. The idea of Earth as an alien mystery flips our usual perspective completely. We've always been the curious ones, the cosmic toddlers pressing our faces against the window of the universe. But what if someday the universe presses back? What if another species, somewhere far beyond our own galaxy, looks at Earth the same way we looked at 3IATLAS, something unfamiliar racing across the stars, leaving scientists baffled and inspired? For us, that object sparked an excitement because it came from somewhere else. For them, Earth would do the same. Except this time, the story we tell isn't about visitors coming to us. It's about us being the visitors, even if unintentionally. The thought alone is hauntingly poetic. Our planet, once the cradle of life, drifting silently into another star system. The oceans long frozen, the continents encased in ice, skyscrapers reduced to glacial silhouettes. Yet from afar, Earth would still sparkle faintly blue, a ghost of its former self. To an alien astronomer, that shimmering color would scream of mystery. Maybe they'd run simulations trying to guess what kind of chemistry could create such hues. Maybe they'd speculate that this world once hosted oceans of ammonia or methane seas. Or maybe, just maybe, they'd realize the truth. That color is the fingerprint of a living world that used to exist. And how would they interpret the signs we've left behind? The artificial satellites orbiting above, still circling long after humanity's gone, would puzzle them. To us, they're the leftovers of human progress. To them, they'd be fragments of design, objects too symmetrical, too deliberate to be natural. An alien scientist might whisper to their colleague, "These patterns aren't random. This planet built things." Imagine the excitement in their voice, the same kind we felt when we found the first exoplanet, or when we heard the first repeating fast radio burst. Discovery has no species. It's a universal emotion. Of course, the irony here is delicious. While we spend billions of dollars and decades of research searching for habitable worlds, some distant civilization might one day be doing the same thing and find us instead. But what they'll find won't be the vibrant, noisy, internet-obsessed Earth we know. They'll see the aftermath, a relic. And in their curiosity, they might reconstruct our story, piecing together our atmosphere, our geological history, our chemical fingerprints. To them, we'll be ancient history, a story written in ice and dust. It's also strangely comforting, because in the vast emptiness of space, where most planets are cold, airless, and anonymous, Earth would still stand out. We'd still be the oddball, the blue marble that once danced around a yellow star, the one that had music, laughter, and Wi-Fi. Even after everything fades, our planet would carry traces of us, tiny chemical whispers saying, "We were here." And just as we speculate about other civilizations, they would speculate about us. Maybe they'd wonder if we still existed somewhere else, having left our frozen home behind. Maybe they'd send probes, eager to uncover our secrets. Maybe they'd mourn our loss or fear what could have caused it. It's funny to think that in their research papers or whatever they use instead, we'd be reduced to a line of data and a hopeful question mark. The great mysteries of planet 3I, Earth, evidence of prior civilization. So, when we look at the sky tonight, spotting stars like tiny holes punched in the darkness, it's worth remembering. One day, we might not just be the ones looking out. We might be the ones being found. The universe has a sense of irony, and it loves to remind us that perspective is everything. After all, to us, 3IATLAS was just a brief visitor, a spark of wonder that came and went. But to someone else someday, we might be exactly that. A flash of mystery crossing their sky, a fleeting question with no clear answer. And, maybe, somewhere in that distant civilization's classroom, a young alien will stare at a hologram of our frozen world and whisper, "Do you think someone once lived there?" And the teacher might smile and say, "Perhaps. The universe is full of ghosts with stories to tell." Little would they know. We were the ones who asked that question first. 3IATLAS, officially called C29U6, Atlas, is one of the most elusive travelers ever to wander into our cosmic backyard. Imagine the Milky Way as a bustling city of stars, planets, and asteroids, all orbiting neatly in their own neighborhoods. Every now and then, though, a mysterious stranger wanders through town without an invitation, doesn't stay long enough for introductions, and vanishes before we can even say, "Hey, where are you from?" That's what 3IATLAS was. An interstellar hitchhiker, a comet that came from somewhere beyond our solar system, zipped past the sun, and was gone before humanity even finished arguing about whether it should be called a comet, an asteroid, or a cosmic troublemaker. To understand how extraordinary 3IATLAS is, you have to realize how rare it is to even see something like it. Space is vast, so vast that most interstellar travelers pass unseen, like dust motes floating through a cathedral. But every so often, one of these wayward wanderers gets caught in the faint gravitational handshake of our sun. It doesn't stay long, but it gives astronomers a tantalizing peek into another solar system's history. 3IATLAS was only the third confirmed visitor of this kind. Before it, there was the cigar-shaped mystery of ʻOumuamua and the comet-like speedster 2I Borisov. Each of them carried a story, written not in words, but in the dust, ice, and rock forged around distant stars billions of years ago. When astronomers first detected 3IATLAS in 2019, it was already moving too fast to belong to our solar system, over 60 kilometers per second. For context, that's fast enough to leave the solar system entirely, and still have time to complain about traffic. Its orbit wasn't a neat ellipse like our planet's, but a hyperbolic curve, meaning it came from elsewhere and would never return. It was a one-time guest, a cosmic drive-by. Yet, in those brief months of observation, this alien ice ball told us something extraordinary. The galaxy is full of stories that occasionally drift into our path, and if we're quick enough, we can catch a few before they disappear forever. What made 3IATLAS especially fascinating was its fragility. As it approached the sun, the heat tore it apart. Astronomers watched as the comet began to disintegrate, its icy surface boiling into vapor, shedding debris like confetti at a cosmic parade. It was a slow-motion act of destruction, but one that revealed its internal secrets. The chemical composition, its gases, its dust, hinted at an origin around another star, one possibly older and cooler than our sun. Its materials weren't identical to those of comets we know, which makes sense. 3IATLAS was forged in an alien nursery, in a place with its own chemistry and cosmic weather. Studying it was like tasting a drop of rain from another planet's storm. For astronomers, this was a golden opportunity. Interstellar visitors are like messages in bottles drifting across the galaxy. Each one tells you something about where it came from, what kind of star it orbited, what temperatures shaped it, what cosmic forces sculpted it. Most of these visitors form when planets are young, and the gravitational chaos of their birth flings leftover debris into deep space. These fragments then wander through the galaxy for millions, even billions of years, until chance brings one close to a foreign star. So, when 3IATLAS passed through, we were peeking into a story that began light years away, long before Earth even had multicellular life. Now, here's the really mind-bending part. Statistically, there could be trillions of such objects roaming between the stars. They're the cosmic drifters, nomads without a home system. And most of them will never be found. Our telescopes catch only a few. Those that happen to pass close enough, reflect enough sunlight, and avoid breaking apart too soon. The rest are invisible, cold, and alone, gliding silently through the galactic dark. They could carry exotic materials, ancient isotopes, or even prebiotic molecules, tiny seeds of life's chemistry, spread across the cosmos like dandelion fluff on a universal breeze. 3IATLAS might not have been the prettiest visitor. It didn't have the dramatic shape of ʻOumuamua, or the perfect tail of a textbook comet. But it was important in a subtler way. It reminded us that the universe is full of travelers, and that solar systems are not sealed boxes. The borders between stars are porous. Gravity is the passport that gets you through. 3IATLAS may have been exiled from its home, but it carried its origins with it. Chemical fingerprints that spoke of another world's birth and death. It was, in a way, cosmic memory made solid. When we think about that, it makes the idea of Earth becoming such a wanderer even more profound. If someday our planet drifts into the dark, we'll be joining the same family as 3IATLAS. We'll be one of the galaxy's countless orphans, planets, asteroids, and comets cast adrift by the restless physics of gravity. But unlike any of them, Earth would carry something unique. The remains of a civilization that once looked to the stars and wondered about wanderers like Atlas. In that sense, we'd be the most ironic interstellar traveler imaginable. The observer turned observed, the scientist turned a specimen. Astronomers sometimes joke that every interstellar object is like a postcard from another solar system. 3IATLAS's message was short, burned around the edges and written in chemical ink we're still learning to read, but it said something unmistakable. You're not alone. The galaxy is restless, and its stories don't stay put. Each time one of these visitors passes through, it shakes our cosmic imagination. It reminds us that planets can wander, stars can share debris, and nothing in the universe is truly stationary. Everything drifts, even us. So, next time you look up at the stars, remember that somewhere out there, countless Atlas-like travelers are gliding between them. Pieces of other worlds passing silently through the dark. Some may carry the ingredients for life. Some may have seen entire civilizations rise and fall as they moved between suns. And maybe, just maybe, one day, another planet will look up at the sky and see us streaking by, a faint blue glimmer with a strange chemical signature, whispering across the galaxy. We were here. For Earth to become an interstellar traveler, something dramatic would have to happen. Maybe our sun goes through a violent phase, or a passing star's gravity tugs too hard. Picture our planet being gently yeeted out of the solar system, drifting into the dark. No sunrises, no sunsets, just eternal night. Cities would freeze, oceans would solidify, and every frozen selfie would be your last. Yet, while humanity would be gone, the planet itself might continue its silent voyage through space, a frozen time capsule waiting to confuse some curious aliens millions of years later. But how does something as massive as Earth actually get kicked out of its solar system? It's not as simple as a dramatic explosion or some science fiction tractor beam. In reality, cosmic eviction happens through something much sneakier: gravitational chaos. Our solar system looks calm, but it's basically a long-running physics experiment powered by mutual attraction. Every planet tugs on every other planet. Every asteroid feels the pull of the big ones, and every comet flirts with disaster. Most of the time, it all balances out nicely. But if you introduce one wrong variable, say, a rogue star drifting too close, or a massive gas giant shifting its orbit slightly, the delicate dance can spiral into something catastrophic. Let's say a wandering star passes near our solar system. Near, in astronomical terms, means maybe half a light year away, farther than Pluto, but close enough for its gravity to stir trouble. Over thousands of years, its pull could subtly distort the orbits of the outer planets. Jupiter, the heavyweight of our neighborhood, might wobble ever so slightly, and that wobble could ripple inward. If Jupiter's orbit changed enough, its immense gravity could begin tossing smaller objects, asteroids, moons, or even planets, out of their stable paths. And given enough time, one unlucky planet could be launched out of the solar system entirely. Earth could be that unlucky one. If that happened, it wouldn't be a dramatic movie moment. You wouldn't see the planet suddenly accelerate into darkness. Instead, over centuries, the sky would slowly change. The sun would grow smaller, dimmer, colder. Our days would stretch into endless twilight, and the air would bite with a chill no heater could fight. At first, only the poles would freeze solid, but soon frost would creep toward the equator. Deserts would turn to tundra, forests to crystal sculptures, and eventually even the oceans would lock under ice. The last flicker of civilization might huddle around geothermal vents or nuclear-powered shelters watching the sun fade into a distant star, like a memory they could no longer touch. Without sunlight, photosynthesis would stop. Plants would wither, animals would vanish, and the air would slowly thicken with the gases of decay. The atmosphere would condense and freeze, forming faint layers of frozen nitrogen and oxygen on the ground. Imagine the sky itself falling, our breathable air turning to snow. It's the ultimate deep freeze, and Earth would become what scientists call a rogue planet, wandering the galaxy without a home star. But even in that frozen exile, Earth wouldn't be entirely dead. Its heart, the molten core, would still pulse with residual heat, a relic of its fiery youth. Deep underground, volcanic activity might continue for millions of years. And where there's heat, there's the possibility of life. Not the kind we know, basking in sunlight, but the kind that thrives in the shadows. Bacteria, fungi, and extremophiles that feed off chemical reactions in the dark. They could persist in underground pockets, feeding on warmth from the mantle, oblivious to the silent apocalypse above. For them, the end of sunlight might not even register. Life, after all, is annoyingly good at finding loopholes. As Earth drifted farther from the sun, it would pass through regions of space littered with dust, ice, and maybe even the outskirts of other star systems. It could become a galactic hitchhiker, coasting through interstellar space for billions of years. Occasionally, it might pass close enough to another star for a fleeting moment of warmth. Imagine the frozen planet bathed in faint starlight once every 100 million years, like a ghost catching a glimpse of the living world before sinking back into the dark. If, by some astronomical miracle, Earth approached another star system closely enough, it could be captured by that star's gravity, becoming part of a new solar family. It might orbit a new sun, thaw slightly, and glow faintly with renewed energy. But that's a long shot. The odds of capture are vanishingly small. Most rogue planets are destined to wander forever, slipping quietly through the galaxy's vast, cold corridors. From a cosmic perspective, Earth going rogue wouldn't be unusual. Astronomers believe that billions of rogue planets already drift between the stars. Planets that were once part of thriving systems, flung out during chaotic youth or stellar collisions. Our planet would simply be joining the galactic club of loners. And yet, it would be unique. A world that once knew life, oceans, cities, and self-awareness. A world that had the conversations about its own fate and recorded them in podcasts and documentaries. If aliens ever found it, Earth would be unlike any other rogue world they'd ever studied. A planet that once dreamed of the stars before being cast among them. It's oddly poetic to imagine the planet we call home becoming a drifter. It spent billions of years orbiting a warm, golden star, growing forests, inventing civilizations, building telescopes, and asking questions about the cosmos. And then, one day, the cosmos would answer, just not in the way we expected. The sun, our lifelong partner, would watch us drift away, growing smaller until it vanished entirely. Earth would continue on its path, a blue ember fading to black, carrying every trace of our existence frozen in place. So, if you ever feel small thinking about your place in the universe, remember this. Someday, the entire planet might be just as lost as you feel now. Adrift, alone, yet still shining faintly with the memory of life. A lonely marble gliding through forever, waiting for someone, somewhere to notice and wonder, what happened here? If alien scientists found our drifting Earth, they'd probably treat it the way we treat meteorites. Slice it, scan it, and freak out when something weird shows up. They'd notice oxygen in the atmosphere, a huge clue that something alive once stirred the air, and traces of plastics scattered everywhere. Imagine their lab conversation. This planet had life, but it also covered itself in flexible polymers for reasons? Earth would be a strange museum exhibit, half natural wonder, half landfill. Somewhere, an alien kid might even do a science project titled The Planet That Choked Itself. Let's picture it. A team of extraterrestrial researchers approaches our frozen world, their ship gliding silently through the interstellar dark. From orbit, Earth looks like a glittering marble half buried in frost. The once blue oceans are white with ice, the continents, glazed in frozen atmosphere, gleam under the faint light of distant stars. To the aliens, it's perfect. A world preserved by cold, like nature's own laboratory sample. They'd send probes swooping down, instruments humming, ready to perform what amounts to a cosmic autopsy. The first thing they'd notice is chemical imbalance. Most lifeless planets have atmospheres in equilibrium. Carbon dioxide, methane, nitrogen, and other gases blended in ways that don't change much over time. But Earth's air would tell a different story. Even after eons of decay, there would still be unusual traces of oxygen bound in minerals and ice. Oxygen is the biggest gossip in the chemical world. It only hangs around in large amounts when something keeps making it. Life. Photosynthetic organisms like plants, algae, and cyanobacteria were Earth's tireless oxygen factories for billions of years. The aliens would see that fingerprint immediately and realize they'd stumbled upon a planet that once breathed. Next, they'd find our cities. To them, these sprawling geometric ruins would seem far too structured to be natural. Skyscrapers, bridges, roads, everything built along grids and straight lines. Nature prefers chaos. Intelligent life prefers right angles. Even if the buildings had long since crumbled into icy rubble, their outlines would remain, etched into the landscape. Drones would hover over New York's frozen skyline, capturing eerie images of glass towers sealed in ice. The aliens might mistake them for crystalline growths, until they spot the repeating windows and symmetrical designs. Then the whispers would begin among the research team. These structures were constructed. And then the plastics. Oh, the plastics. Even after billions of years, much of that stuff would still be intact, stubbornly refusing to break down. The aliens might scoop up samples from beaches and landfills, baffled by the synthetic polymers that don't match any natural geological process. They'd run tests, vaporize samples, and find complex carbon chains, molecules far too deliberate to have formed by accident. They engineered this material, one might say. But for what? When they find microplastics in the sediment of every ocean and the residue of fossil fuels baked into the atmosphere, they'd realize this species didn't just live here, it transformed the planet itself. They'd probably spend years debating whether humanity was intelligent or just industrious. One alien scholar might argue, clearly they were advanced. Look at their infrastructure and energy use. Another might counter, yes, but they drowned their own biosphere in synthetic waste. That's not exactly top-tier decision-making. It would be the first intergalactic academic feud over whether Earthlings were geniuses or cosmic fools. Of course, once they start digging deeper, literally, they'd find even stranger relics. Buried cables, fossilized electronics, and networks of metal veins running through the ground. Power plants, subways, data centers. To them, it would look like the planet itself had a nervous system, a lattice of artificial arteries connecting the globe. If they realized those systems once carried information rather than blood, they might understand that this was a world where intelligence didn't just evolve, it networked. In their laboratories, they'd reconstruct fragments of our technology. A smartphone, perhaps, thawed from a glacier. They'd analyze the circuits, detect traces of electrical patterns, and eventually decode what we once used it for. The moment they play back a recording, maybe a snippet of human laughter or a song, it would be the first time anyone had heard a human voice in millions of years. That single sound would ripple through their civilization. It wouldn't matter that they couldn't understand the words. The emotional timbre, the rhythm, the warmth would speak volumes. They'd realize this wasn't just a world with chemistry, it was a world with culture. But the deeper they study, the stranger Earth would seem. They'd find evidence of widespread agriculture, fossilized crops, irrigation channels, and the remnants of domesticated species. Yet they'd also find mass extinctions, layers of soot from industrial activity, and rising carbon levels trapped in the ice. It would be obvious that Earth's dominant species not only mastered its environment, but also destabilized it. That's where the alien historians would get philosophical. Perhaps they reached a point of technological power faster than they developed the wisdom to control it, one might speculate. Another might muse, or perhaps destruction was simply part of their nature. Eventually, they'd build a narrative from their findings. They'd chart Earth's geological history, identify its ancient oceans and continents, trace the rise and fall of its biosphere, and finally map the era of humanity. In museums across their world, Earth would become a symbol, a case study in both wonder and warning. Visitors would stare at holographic recreations of our cities, listen to the eerie echo of our languages, and marvel at the creatures that once roamed our surface. This, their guides would say, was a world that achieved consciousness. It dreamed, it built, and it vanished. And somewhere, perhaps on a small alien child's desk, there would be a science fair project with a perfect title card, "The Planet That Choked Itself." The display would feature a frozen blue sphere encased in glass, streaked with miniature plastic continents. The summary would read something like this. Subject, Earth, a planet that once supported intelligent life. Evidence of creativity, technology, and self-awareness. Primary cause of extinction, poor waste management and atmospheric misjudgment. The child would get top marks, of course, because the story of Earth isn't just tragic, it's captivating. In the end, our drifting planet would become what every civilization secretly hopes to leave behind, a story worth telling. The cosmic autopsy wouldn't just reveal how we died, it would show how astonishingly alive we once were. Getting thrown out of a solar system isn't easy. It takes a lot of gravitational drama. Usually, it happens when a large planet like Jupiter flings smaller objects outward during chaotic orbital dances. Earth would need a strong cosmic shove, perhaps from a wandering star passing nearby. It's like the universe's version of being kicked out of a party, except the party is the solar system, and the bouncer is gravity. The result? Earth hurtles into the void at tens of kilometers per second, no longer bound to any sun. Congratulations, we're now officially interstellar. But let's break that down, because the universe doesn't hand out eviction notices casually. The physics of planetary ejection is all about balance. Specifically, the delicate gravitational equilibrium that keeps a planet in orbit. Earth's current orbit is like a perfect cosmic handshake between our planet's momentum, trying to fling us outward, and the sun's gravity, pulling us inward. If that balance tips too far in either direction, things start to get weird. And by weird, I mean apocalyptic. For Earth to be ejected, something has to give us a push strong enough to overcome the sun's gravitational grip. That grip is no joke. Even from 150 million kilometers away, the sun keeps us in a stable circular path, one that's remained mostly unchanged for billions of years. To escape, Earth would need to reach what physicists call solar escape velocity. For us, that's about 42 kilometers per second, roughly 150,000 kilometers per hour. To put it in perspective, that's like leaving home so fast you'd reach the moon in less than 3 hours. Now, how do you make an entire planet move that fast? There are 3 main suspects in this cosmic crime story: gravitational interactions, stellar encounters, and internal instability. First up, gravitational interactions. This is when the planets themselves start playing a dangerous game of interplanetary billiards. In the early days of any solar system, when planets are still finding their orbits, collisions and ejections are common. It's the celestial equivalent of musical chairs, except the loser gets launched into space forever. Even in mature systems like ours, gravitational nudges from giant planets can build up over time. If Jupiter or Saturn slightly altered their orbits, their immense gravity could start tossing smaller worlds around like cosmic marbles. One wrong move, one orbital resonance too many, and Earth could be slingshotted outward. Then there's the possibility of a stellar encounter, a wandering star passing near our solar system. Stars aren't static. They drift through the galaxy, weaving past one another on million-year timescales. Statistically, one will eventually pass within a few trillion kilometers of us. That might sound like plenty of breathing room, but in gravitational terms, it's close enough to cause chaos. The newcomer's pull could distort the orbits of the outer planets, Neptune, Uranus, even Jupiter. And as those orbits shift, the entire system's delicate architecture could unravel. It wouldn't happen overnight. For thousands of years, orbital paths would stretch, twist, and precess like cosmic rubber bands until one finally snaps, and Earth, our unassuming blue marble, gets flung into the interstellar dark. And then there's internal instability, the slow, subtle changes within our own sun. Stars evolve, and as they do, their gravitational hold weakens. Billions of years from now, when our sun begins to run low on hydrogen, it will swell into a red giant, losing mass in the process. Less mass means less gravity. Planets will drift outward as if the sun were letting go of its leash. For the inner worlds, that might mean being swallowed whole, but for others, Earth included, it could mean escape. The same stellar aging that destroys Mercury and Venus could free us. It is poetic, in a slightly horrifying way. The star that gave us life might one day set us loose into the galaxy. Now, once Earth's leash snaps, things get fast, really fast. Our planet would accelerate as it leaves the sun's gravitational well, reaching speeds of tens of kilometers per second. From a human perspective, it would look serene, almost gentle, a slow fading of sunlight over centuries. But from the outside, Earth would be rocketing through space like a marble shot from a slingshot the size of a star, I'd say. It would pass the orbit of Neptune in a few decades, Pluto in a century, and then drift beyond the heliopause, the invisible edge of our solar bubble. Beyond that lies true interstellar space. No solar wind, no magnetic shield, just the vast emptiness between stars. For physicists, the fascinating part isn't just that this can happen, it's that it probably already has millions of times over. Every galaxy is filled with rogue planets, worlds ejected by gravity's chaotic choreography. Some may still have moons, atmospheres, even liquid oceans deep beneath frozen shells. Each one is a reminder that planetary systems are dynamic, unpredictable, and sometimes downright violent. The cosmos loves order, but it's also fond of a little chaos to keep things interesting. Let's not forget the math of it all. Every push and pull between celestial bodies is governed by Newton's laws, those old but sturdy rules that describe how masses attract each other. The gravitational tug between two planets depends on their masses and how far apart they are. Change that distance even slightly, and the force shifts. Over millions of years, those shifts accumulate. A tiny nudge here, a gravitational assist there, and suddenly you've rewritten the solar system's script. What feels stable to us is, on geological timescales, just a long pause between acts. If Earth were to go rogue, it wouldn't be because the universe hates us. It would simply be physics doing what physics does best, rearranging the furniture of existence. Our ejection wouldn't be personal. It would be procedural. Planets are like celestial renters, and gravity is the landlord. Stay in your orbit, pay your balance of kinetic energy and potential energy, and you're fine. Miss a few payments, and you're out. So, if one day the sun loosens its grip, or Jupiter decides to play rough, Earth could find itself sailing through the galaxy, no longer tied to anyone's gravity but its own. A lonely sphere coasting silently between stars, forever carrying the echo of the system that once called it home. And in the grand equation of the cosmos, it would all come down to one simple truth. Gravity giveth, and gravity yeeteth away. Without sunlight, Earth would turn into a popsicle within weeks. The surface temperature would drop below 200 degrees Celsius, and the oceans would freeze from the top down. The only warmth left would come from Earth's core, slowly fading like the last ember in a dying campfire. A few stubborn microbes deep underground might survive, clinging to geothermal vents. Humanity's monuments would freeze solid, perfectly preserved, so if aliens ever landed, the Eiffel Tower would still be there, covered in frost, looking fabulous in space's eternal winter. But let's not skip straight to the end. The deep freeze of a rogue Earth would unfold like a slow-motion apocalypse. The moment sunlight begins to fade, the cascade of changes starts almost instantly. The first thing we'd notice is the color of the sky. As the sun dwindles, the blue fades into a permanent twilight gray. Within a few days, the familiar cycle of day and night becomes meaningless. Shadows blur. Time loses rhythm. The last sunset on Earth wouldn't be a fiery red farewell. It would be quiet, almost gentle, the sky dimming into perpetual dusk. Temperatures would plummet fast. Within a week of losing solar warmth, the average surface temperature would fall below freezing. Plants would be the first to die. Photosynthesis needs sunlight, and without it, the great green engines of Earth would sputter out. Forests would wither. Grasslands would turn brittle, and the air would start to lose its oxygen. As animals succumbed, the planet's soundscape, the chorus of birds, insects, waves, and wind, would fall silent. Earth would become eerily still, save for the groaning of ice expanding across oceans and rivers. Water would behave strangely in this new world. The oceans wouldn't freeze instantly, thanks to their immense thermal mass, but as surface temperatures dropped, ice would begin forming across the top. Unlike most substances, water expands when it freezes, forming a solid crust that insulates the liquid below. That means the deep oceans would stay fluid for quite a while, centuries, even in millennia, protected by a thick shell of ice. Beneath that frozen armor, a slow, dark ocean would persist, swirling faintly from geothermal heat rising from the planet's core. It would be the last refuge for life on Earth, a shadowy kingdom of bacteria and extremophiles that never cared much for sunlight in the first place. The atmosphere would begin to collapse next. Air is held close to the planet by gravity, but temperature controls how it behaves. As the world cools, gases condense. Carbon dioxide would freeze first, forming dry ice snow that settles across the continents like alien frost. Nitrogen and oxygen, our old breathable friends, would soon follow, crystallizing into fragile flakes that glitter faintly under starlight. Eventually, the sky would clear completely, not because of weather, but because there'd be nothing left to move. The air itself would lie frozen on the ground, a thin, ghostly veneer over a dead world. And yet, the planet would not be entirely dark. The frozen crust would occasionally crack from thermal stress, releasing plumes of trapped gases and brief flashes of volcanic fire. Those eruptions would paint the icy wasteland with fleeting color, a reminder that beneath the surface, Earth's core still glowed faintly with heat. Down there, deep in the mantle, molten rock would continue to churn slowly, insulated from the surface cold. That heat would radiate upward, keeping pockets of water liquid in underground reservoirs. Life might hang on there, in microbial communities feeding on chemical reactions instead of sunlight. They'd be the last inheritors of Earth, living fossils in the dark, unaware they were the final witnesses to a once bright world. Meanwhile, the frozen surface would become a mausoleum. Every human artifact, from crumbling cities to coffee mugs left in abandoned kitchens, would be locked in place by the cold. Unlike the warm, erosive forces of wind and rain, the freeze would preserve everything. Books would remain intact, their pages stiff with frost. Highways would still trace the outlines of continents. Satellites would keep orbiting for centuries, their silent circuits occasionally catching glimmers of distant starlight. Even plastic bottles and billboards would survive, frozen mid-decay, waiting for the next civilization to wonder what bizarre creatures left them behind. Over time, the temperature would continue to drop until Earth reached a new equilibrium with the background radiation of space, about minus 270 degrees Celsius. That's just a few degrees above absolute zero, the coldest temperature possible. At that point, the molecules that once made up oceans, mountains, and living things would barely vibrate. Movement itself would almost stop. If you touched the frozen surface and somehow survived to do so, it would feel harder than steel and more fragile than glass. One tap could shatter an icicle that used to be a skyscraper. And yet, in that silence, there's a strange kind of beauty. The planet would glow faintly in the infrared spectrum, its last warmth radiating into space like the dying note of a song. From far away, it might appear as a dim, ghostly orb, glinting with frozen clouds and fractured light. It would be easy to mistake it for a comet or an unusually reflective asteroid. No one could tell from a glance that it once teemed with color, laughter, and chaos. Over millions of years, micrometeorites would pepper the surface, leaving small craters that sparkle with ice dust. Tectonic activity, though slowed, might still nudge continents slightly, breaking apart the outlines of what used to be nations. Mountains would erode not through weather, but through time itself, atoms slowly rearranging in the cold. Eventually, even the core would cool completely, turning solid. When that happens, Earth would lose its magnetic field, its last shield against cosmic radiation. From that point onward, it would be utterly exposed, a frozen relic adrift in the galaxy's endless dark. And yet, if some alien explorers ever stumbled upon it, Earth would still tell its story beautifully. They would find continents locked under crystal shells, oceans trapped beneath layers of translucent ice, and cities perfectly preserved in frozen time. They'd see the intricate structures and wonder what kind of beings built them. They'd find fossils, artifacts, and perhaps even messages etched into metal plates or digital code, declaring, "We once lived here." It's a chilling image, literally and metaphorically. But in a way, it's comforting too. Because even as the world froze and faded into cosmic night, it wouldn't vanish. It would simply change form. From a living planet to a monument, a silent sculpture commemorating the improbable moment when life, for a brief time, warmed this small blue rock. The last ember of Earth might not burn with fire, but with memory, echoing softly through the void, a frozen whisper that once upon a time the cold universe was warm. Even as a rogue world, Earth wouldn't be completely dark. Some rogue planets might glow faintly with residual heat, their atmospheres shimmering with faint auroras from cosmic radiation. Imagine looking at Earth from light years away, a dim blue ghost gliding through the dark, its frozen clouds reflecting distant starlight. It would be hauntingly beautiful, like a forgotten jewel still drifting through time. Somewhere, an alien telescope might catch that glint and wonder, what kind of world shines so sadly in the dark? Even without a sun to orbit, Earth would still have a subtle radiance, a last echo of its once luminous life. Deep inside, its molten core would still churn for a while, leaking out the final whispers of geothermal heat. That warmth would creep toward the surface, escaping through cracks in the crust and faintly illuminating the ground in shades of red and orange infrared light, colors invisible to our eyes but radiant to sensitive instruments. If you could stand on the surface and somehow survive, you might see faint halos along the horizon, not from sunlight, but from particles colliding in the thin, frozen air. The whole world would glow like an ember that refuses to die out completely. There's also another kind of light. The light that comes from the universe itself. Cosmic rays, high-energy particles born from exploding stars and colliding galaxies, would constantly slam into Earth's thin remains of atmosphere. Each impact would set off tiny bursts of fluorescence, brief flickers of energy that shimmer like ghostly lightning. The auroras we once admired near the poles would now paint the entire sky, weaving green and violet ribbons from horizon to horizon. They'd move silently, fueled not by solar winds anymore, but by the endless radiation sea that fills the galaxy. That auroral glow would be Earth's final act of defiance, a reminder that even in exile, beauty persists. It wouldn't be visible to human eyes anymore, but from space, a sensitive telescope could pick it up. Faint but rhythmic, a cosmic heartbeat in color. Astronomers on another world might notice those pulses and wonder if they're natural or something more. Perhaps a signal, perhaps a beacon, perhaps a world refusing to be forgotten. In time, even the light from the core would fade, but that wouldn't mean complete darkness. Rogue planets can sometimes steal light in strange ways. Earth's frozen atmosphere would act like a vast, cracked mirror, catching starlight and bending it around itself. Every distant sun in the galaxy would contribute a little shimmer, a faint reflection on the icy surface. The planet would twinkle, subtly, mysteriously, like a drifting snowflake illuminated by the cosmic background. To an alien eye, Earth would appear as a wandering spark, gliding gracefully through the black ocean of space. But here's where it gets poetic. The light from Earth wouldn't just be reflection, it would be history. Every photon that escaped from our surface carries with it a record of what once was. Faint microwaves from our radio age, infrared glows from our cities, even the old laser pulses from scientific experiments. All of them still travel outward, a faint, expanding bubble of electromagnetic memory. Long after our planet froze, those signals would continue on, broadcasting the story of a civilization that once lit up its nights with electricity and wonder. To an alien civilization with the right instruments, Earth would still be glowing in a very literal sense, with echoes of human technology, like ghosts speaking in static. Imagine one of those aliens detecting it. They'd train their sensors on the faint moving light, note its strange spectrum, and realize it doesn't match a star or a comet. They'd see the frozen surface, the reflective clouds, the weak infrared warmth of a once living core. Maybe they'd call it something poetic, too. The weeping planet, or the wandering mirror. And perhaps somewhere in their research logs, they'd note that its chemical composition suggested it had once been habitable. One scientist might squint at the data and mutter, "It shines, but not like a living world. It shines like a memory." What's eerie about the universe is how good it is at remembering light. When we look at distant galaxies, we're seeing them as they were millions of years ago. The light takes that long to reach us, carrying images of the past. In that same way, Earth's fading glow would carry its own history forward. Our blue marble turned into a time capsule of light. Even as it grew dim, even as its oceans turned to stone, the photons once born from human laughter, from firelight, from auroras, and from lightning storms would continue their endless journey outward. Somewhere, someday, someone, or something, might intercept that light and reconstruct who we were, the way archaeologists decode fossils from ancient bones. It's strange to think that even after the last heartbeat, the last sound, the last trace of warmth, Earth wouldn't truly vanish. In physics, light never dies. It only travels. Every sunrise that ever graced our skies, every reflection of moonlight on water, every candle, every spark, it's all still out there, racing across the cosmos at the speed of truth. So when we imagine our rogue planet glowing faintly in the dark, what we're really imagining is a mirror of everything we ever were. If you could hover near it and look down, the view would be breathtaking. The continents would be ghostly outlines beneath translucent ice, mountain ranges catching faint reflections of starlight. The atmosphere, thin and patchy, would flicker with static auroras, painting the frozen world in eerie greens and blues. Space around it would be utterly silent, the kind of silence so complete it becomes a presence in itself. And yet, the planet would still shine. Maybe that's what makes the image so haunting. The light of a wandering Earth wouldn't be bright enough to warm, but it would be bright enough to remember. It would drift through space as the ultimate relic of existence, a dim, persistent glow saying, "Something once lived here. Something once burned here." And if an alien civilization ever spotted it, they might gather around their equivalent of a telescope and stare, captivated at the faint light of a dead world. Someone among them, perhaps a poet, perhaps a scientist, might whisper, "Look how it shines. It's beautiful, but sad." And another might answer, "Maybe all beauty is in the end." For the rest of time, that light would continue onward, a pale ghost in the darkness, a world that once had sunlight in its bones, a planet that refused to disappear quietly. When aliens study a rogue Earth, their data would be confusing. They'd find nitrogen and oxygen, fossil fuels, and faint radiation signatures. They might assume it once had intelligent life, or maybe that it was some kind of bioengineered world. One scientist might propose, maybe it was inhabited by organisms that built giant metallic structures and then left. Another might say, or maybe the structures built them. Every alien conspiracy theorist would have a field day. It's comforting to know paranoia is probably universal. Let's step into their shoes, or whatever their version of shoes happens to be. Imagine a civilization far more advanced than ours, equipped with sensors capable of analyzing worlds light years away in exquisite detail. Their telescopes pick up the faint spectral signature of our rogue planet, drifting silently through the dark. The first readings would look promising. Traces of water, oxygen, carbon compounds. To any scientist, the combination screams potential life. But as they dig deeper into the data, the picture would start to blur into contradiction. The ratios are all wrong. There's too much nitrogen, not enough methane. There are weird hydrocarbons that don't match any natural geological model. Some regions seem coated in unusual metallic alloys, and, most puzzling of all, there's a fine layer of strange synthetic material blanketing the continents like a thin, invisible film. To us, that would just be the remnants of plastics, microfibers, and industrial dust. But to them, it might look like deliberate planetary engineering. Maybe they'd interpret it as a terraforming project gone wrong, or perhaps a planetary-scale biosphere experiment abandoned halfway through. They'd zoom in on the cities, those geometric scars in the landscape, perfectly rectangular grids that defy natural formation. No volcano, river, or tectonic plate moves that symmetrically. This, one alien researcher would say, is either evidence of intelligence or the strangest geological process in the galaxy. And then they'd find something that would truly mess with their understanding. Fossil fuels. To us, it's just ancient carbon buried and burned. But to an alien scientist, that discovery would suggest that the planet once stored enormous amounts of biological material underground, then re-released it into the atmosphere. The chemical residue of our industrial age would linger for millions of years, preserved in ice or rock. Imagine their confusion. a planet that seems to have intentionally released greenhouse gases, changing its own climate. But why? Their lead researcher would ask. What kind of species uses ancient corpses of its own biosphere as fuel? The others might exchange looks of disbelief. Perhaps ritualistic, one might suggest, trying to make sense of humanity's collective habit of turning its past life forms into progress. They'd scan for radioactivity and stumble upon faint isotopic anomalies, the signature of nuclear testing. A few might interpret that as evidence of mining or energy extraction. Others, more dramatic, might whisper about planetary warfare. Look, they'd say, localized radiation, cratered structures, heat signatures in once populated areas. It's clear this world destroyed itself. Their equivalent of a late-night talk show would run with it immediately. Was the planet's destruction an accident or something deliberate? Stay tuned after the galactic weather update. But not all aliens would agree. There would be skeptics, the cosmic academics who argue endlessly about interpretation. One camp might insist Earth was once home to biological life that evolved technology and then perished. Another might counter that the evidence points to artificial origin, that the planet itself was built as an experiment. Think about it, one theorist might say. A world with perfect conditions for life, balanced gases, liquid water, stable rotation. It's too convenient. Maybe it was designed. Some fringe thinker might go even further. What if these metallic structures weren't built by life, but for it? Perhaps this planet was a laboratory, a nursery designed to simulate evolution. The academic community would sigh collectively. Ah, the engineered Eden hypothesis again, someone would mutter. Every generation has its pseudoscience. But the idea would stick. Across alien social networks, conspiracy groups would form, debating whether Earth was a natural planet, a failed simulation, or a prototype biosphere abandoned by its creators. Their comments section would be just as messy as ours. The discovery of human artifacts would only deepen the confusion. They'd find satellites, frozen relics still orbiting the planet, covered in cosmic dust, but intact. They'd analyze the shapes, the circuits, the patterns of antennas. One alien engineer might frown. This is technology, clearly, but not ours. It's primitive. No quantum channels, no neural interfacing. They must have been early-stage civilization builders. Another would reply, then where are they now? If they decoded our digital remains, our radio waves, our stored data, our transmissions, it would be like finding the diary of an extinct species written in a lost language. They'd catch snippets of songs, images of people smiling, news broadcasts, instructions on how to microwave leftovers. They'd hear laughter, arguments, speeches, and perhaps the faint echo of 1,000 cat videos. Imagine the confusion of trying to reconstruct a culture from fragments of entertainment. They appeared to worship moving images of themselves. One alien linguist would theorize, perhaps this was a form of social bonding ritual or psychological training. Another would raise a tendril and say, I think it's just nonsense. And yet, beneath the confusion, there would be awe. They'd recognize that this was not a dead rock, not just another icy sphere floating in the dark, but a world that once felt, a world that built, dreamed, and argued. They might marvel at how we covered our planet in art, how we built monuments that reached toward the sky, how we encoded our thoughts into machines. They'd realize, perhaps with quiet reverence, that this world was alive not just biologically, but emotionally. In their final report, perhaps etched into their equivalent of a scientific journal, they'd summarize the findings like this. Object designation. 3I are Earth. Atmospheric composition inconsistent with natural geological equilibrium. Evidence of organic chemistry and structural design. Probable signs of intelligence. Planetary status. Extinct but remarkable. Classification. Artifact world. And maybe, late at night after the data has been logged and the debates quieted, one alien scientist would step outside and look up at the stars. They'd think of Earth, the silent sphere drifting alone in the dark, and feel something unexpected, a tug of empathy. Maybe they'd even whisper to themselves, whatever they were, they tried. They reached. They made their mark. In that moment, across unimaginable light years, the line between scientist and subject, observer and observed, would blur. Because to study a lost world like Earth isn't just to analyze. It's to remember that even in the vastness of space, intelligence leaves traces, emotion leaves echoes, and curiosity is a universal constant. Radio waves leak into space constantly, our accidental postcard to the cosmos. Even as Earth drifts, those signals would keep traveling. Decades later, alien receivers might pick up fragments of our civilization. Jazz music, sitcoms, political debates, or, unfortunately, reality TV. Imagine them deciphering a broadcast and concluding that humans worshipped something called the Bachelor. It would be the ultimate archaeological embarrassment, our entire cultural legacy judged by our worst television. What's beautiful and tragic about this is that our electromagnetic fingerprint is already out there, spreading in every direction like ripples in a cosmic pond. Every transmission ever made, from the first Morse code blips to the digital hum of satellite data, is expanding outward at the speed of light. Right now, our earliest broadcasts have already traveled more than 100 light-years into space. Somewhere out there, near distant stars, the first episodes of black and white television are just arriving. If any aliens happen to be listening, their introduction to humanity might be The Lone Ranger, or a speech by Franklin Roosevelt. Or maybe just an early commercial for soap. The cosmos may never forgive us. The first radio waves we sent weren't even meant for anyone beyond Earth. They were byproducts of invention, the side effects of curiosity. But as we filled our skies with transmissions, music, news, television, radar, Wi-Fi, we became an unintentional lighthouse in the dark. For billions of years, the Milky Way was silent. Then, suddenly, one tiny planet started humming. If alien civilizations map the galaxy by radioactivity, Earth would be a flickering beacon of noise surrounded by quiet stars. Of course, our signals aren't strong forever. As they travel, they spread out, thinning into the background static of the universe. The further they go, the harder they are to detect. After a few dozen light-years, the average radio broadcast fades below the cosmic noise level. To hear it, aliens would need enormous receivers, antennae the size of moons, or perhaps swarms of nanoscopic sensors orbiting their worlds. But for a civilization that advanced, eavesdropping on us might be child's play. The real challenge wouldn't be hearing us, it would be understanding what they're hearing. Imagine the confusion. They'd detect bursts of modulated energy, rhythmic and complex, repeating every fraction of a second. They'd decode the patterns, separate the frequencies, and slowly realize that this wasn't random cosmic static. It's structured, artificial. They'd pick out patterns of human speech, perhaps recognize repetition as language, and eventually isolate music. Now imagine their first impression of us coming through a crackling signal. Louis Armstrong's trumpet drifting through the void, or Elvis Presley crooning from across the stars. Humanity's voice carried not through spaceships but through sound waves, turned to light. There's something poetic about that. Long after we're gone, long after our cities freeze and our oceans turn to glass, our songs will still be traveling. Somewhere out there, what a wonderful world is echoing through the galaxy, possibly outliving the world it was written about. Our art, our laughter, our noise, it's all immortalized in electromagnetic form, passing silently through constellations that will never know the warmth of our sun. But then, of course, there's the other side of that legacy. Along with Mozart and Ella Fitzgerald, we've also broadcast soap operas, political rants, and commercial jingles. Imagine aliens picking up an old advertisement for cola and trying to decode it as a religious chant. They offered divine refreshment, one alien scholar might say, apparently consumed through ritual gatherings near luminous rectangles. Another might respond, yes, but they seemed divided. Some worshipped Pepsi, others Coke. If they stumble upon the chaotic energy of human reality television, they might assume we evolved not to build civilizations, but to argue loudly in kitchens. And yet, the idea of being known this way, through our unfiltered emissions, is strangely comforting. We didn't have to send golden records or carefully curated messages, though we did that too. Our existence leaked into the universe naturally, like light spilling through cracks in a window. We couldn't help but announce ourselves. Every airport radar ping, every emergency broadcast, every love song transmitted from an FM tower, it all adds up to a cosmic mixtape of humanity. It's messy, emotional, contradictory, and beautiful in its chaos. Even now, while you're reading this, our planet hums with thousands of overlapping signals. They layer and twist through each other like invisible threads. Cell phone calls bouncing off satellites, GPS pulses timing out nanoseconds, digital packets ferrying cat memes through the atmosphere. All of it leaves faint echoes, a kind of electromagnetic fog surrounding our planet. To aliens, this fog would be unmistakable. A living planet doesn't just reflect light, it radiates culture. And as Earth drifts deeper into the galaxy as a rogue planet, those signals would continue traveling long after the last transmitter goes silent. Long after the atmosphere freezes, the radio bubble would keep expanding, hundreds of light years wide, then thousands. Long after there's no one left to listen, the universe would still hum with the memory of us. And inside that hum, there would be rhythm and meaning, the rise and fall of voices, the syncopation of songs, the static between words. Scientists have long speculated about whether radio waves from other civilizations might be reaching us right now, hidden in the static. If so, then our own transmissions are part of that same conversation, an endless, unintentional dialogue across time and space. We send out signals we'll never hear back from. They echo outward forever, pieces of us that no longer belong to us. Maybe that's the real beauty of it. Even if Earth ends, even if our sun fades, our electromagnetic fingerprint remains woven into the fabric of the cosmos. Somewhere, billions of years from now, those waves might reach a young civilization just beginning to listen. They'll detect a faint hum from deep space, amplify it, and hear fragments, snatches of melody, laughter, static. Perhaps one of them will tilt their head and ask, "What is that?" And another will answer, "I think it's music." In that moment, we'll be remembered, not by our monuments or machines, but by the most human thing of all, our sound. Because while our planet may one day fall silent, the universe will still be playing our greatest hits. As Earth freezes, much of our history would be preserved under layers of ice and rock. Books, buildings, satellites, and buried time capsules would remain almost intact. To aliens, Earth would seem like a crime scene frozen mid-sentence. They might find a McDonald's logo and wonder if it was a sacred symbol, or stumble upon the Internet's remains and assume cats were our ruling species. Either way, our planet would be both a scientific treasure and a comedy goldmine. Imagine Earth millions of years after its final sunset. The surface, once a blur of motion and color, now lies still, a world wrapped in translucent glaciers that stretch from pole to pole. Beneath those frozen layers, the last traces of humanity rest in perfect preservation. Cities that once pulsed with electricity and chatter are entombed like insects in amber. Skyscrapers stand stiff in the frost, their glass facades clouded but unbroken, their steel bones holding shape against eternity. Every street, every doorway, every artifact is locked in a crystalline pause. The planet has become its own museum, one no visitor asked to build, but one that will outlast every civilization that ever set foot upon it. The ice itself would be a historian's dream, and each layer would capture a snapshot of Earth's final days, the chemical signature of its atmosphere, the microscopic debris of its last storms, the soot from its last fires. If aliens drilled through those layers, they could read our environmental history like tree rings in a frozen diary. They'd see the gradual buildup of carbon, the spikes in radiation, the sudden appearance of plastic fibers. This planet, one alien geologist might say while examining the ice, documented its own downfall without meaning to. Every century left a fingerprint. The buried relics would tell their own stories. Libraries, protected from decay by the cold, might still contain books whose pages could be pried apart and read. Imagine an alien archaeologist gently opening a frostbitten copy of The Great Gatsby, trying to decipher why this species was so obsessed with green lights and unattainable dreams. Or another brushing off the cover of a cookbook and marveling at the concept of microwave instructions. They'd probably catalog the texts under primitive philosophy, sustenance and desire. Digital artifacts would be even stranger. Hard drives and flash storage, frozen solid, could survive for millennia. When thawed by alien technology, they'd reveal our archives, billions of photos, emails, and memes. The Internet, that chaotic web of humanity's collective consciousness, would become their Rosetta Stone of confusion. They'd scroll through fragments of social media and wonder if humans communicated primarily through sarcasm and pictures of breakfast. Their visual symbols are complex, one alien linguist might note. This creature, Grumpy Cat, appears to have held significant spiritual power. Deeper still, in vaults designed to outlast time, our deliberate attempts at preservation would await discovery. Real-world projects like the Svalbard Global Seed Vault and the Long Now Foundation's time capsules might endure beneath permafrost, their inscriptions faint but legible. Inside, aliens could find seeds from thousands of plant species, tiny, perfect archives of Earth's biodiversity. They might marvel that this dying species took the time to save the future it would never see. It would speak of foresight, of hope, of an almost childlike faith in continuity. One alien might whisper, "They knew they would end, but they still planted for a tomorrow." Not all discoveries would inspire admiration, though. Some would be baffling. A field of rusted automobiles might look like mechanical herds that once roamed the plains. Stadiums might be mistaken for ritual gathering sites. The melted remains of amusement parks could be interpreted as fortresses or strange ceremonial grounds. Their architecture suggests cycles of competition and consumption, an alien anthropologist might hypothesize, pointing at a frozen roller coaster loop. Perhaps this was a training structure for flight or courage. And then there's branding, our peculiar tendency to stamp symbols on everything we touch. Logos would survive remarkably well, especially those embossed in metal or carved in stone. A golden M could easily outlast a mountain of marble. Aliens might classify it as a recurring religious motif. The cult of McDonald's, they'd call it, mistaking our fast food empire for a global faith. Its shrines were evenly distributed across continents, suggesting universal worship. Somewhere in their museums, a perfectly preserved Happy Meal toy might be displayed beside a tablet inscribed with "In God We Trust." The connection would make them nod solemnly in misunderstanding. But the greatest mystery might come from our satellites. Even as the ground froze solid, the upper reaches of orbit would remain sprinkled with our machines. When alien explorers found them, drifting near the planet like ancient charms, they'd recognize the craftsmanship. These weren't random rocks. They were deliberate. They might trace their orbits and realize they once formed a communication web, encircling the planet in invisible threads. This world spoke to itself through its sky. One alien historian might write, "It built a halo of metal to hear its own voice." Yet, what would fascinate them most wouldn't be our technology or architecture. It would be our contradictions. Beneath the ice, they'd find evidence of compassion alongside greed, beauty beside destruction, a sculpture park frozen mid-snowstorm, a protest sign buried in a glacier, a child's toy next to the fossilized bones of extinct animals. Each discovery would tell a story not of perfection, but of struggle, of a species that dreamed far beyond its limits and paid dearly for it. Eventually, they'd piece together enough fragments to reconstruct a version of us, flawed, ambitious, endlessly curious. They'd see a species that wrote poetry and equations, that built rockets and ruined ecosystems, that fell in love and went to war. They'd realize we weren't gods or fools, but something far more fascinating, hopeful. And in their museums, they'd showcase Earth not as a tragedy, but as a warning wrapped in wonder. Visitors would walk past holograms of frozen cities and preserved forests, reading plaques that say, "The people who tried." Children of other worlds would press their appendages to the glass and stare at the faces of extinct humans, maybe laughing at our fashion choices or expressions. But somewhere, one of them would whisper, "They look alive." Because even in ice, even in silence, even after everything fades, what Earth would leave behind isn't just evidence, it's emotion. A time capsule beneath the ice doesn't just preserve artifacts, it preserves longing. And maybe that's the one thing every intelligent species, no matter how different, will always understand. If we knew Earth was going rogue, humanity might try to adapt, building underground cities powered by nuclear reactors or harnessing geothermal energy. It would be the ultimate survival challenge. Humanity versus the void. We'd live beneath frozen crusts, growing food under artificial light, dreaming of starlight we'd never see again. If aliens ever found us during that stage, they'd probably label us stubborn cosmic mold, refusing to die even when our sun left us. It's hard to imagine what the last age of humanity would look like, but one thing's certain. We wouldn't go quietly. Throughout history, we've made a habit of thriving in places we absolutely shouldn't. We crossed deserts, scaled mountains, lived under oceans, and built homes on continents of ice. Compared to that, surviving a lightless planet sounds, well, okay, still pretty bad, but not impossible. After all, survival isn't about comfort, it's about creativity with deadlines. The first step would be moving underground. As the surface froze, temperatures would plummet so fast that only the deep Earth could offer stability. The planet's crust is like a thick blanket holding in heat from the molten core, and just a few kilometers down, that warmth could mean the difference between extinction and endurance. Massive subterranean cities could be carved beneath old mountain ranges or in the cavities of decommissioned mines. These would become the last beating hearts of civilization, human hives glowing softly in the dark. Energy would be the lifeblood of this underground world. Without sunlight, solar power would be useless, and wind turbines would be buried under glaciers. But the Earth itself would still hum with energy. Geothermal power stations could tap into volcanic heat, converting the planet's inner fire into electricity. Nuclear reactors would shoulder the rest, humming quietly as they kept the lights on, the air warm, and the hydroponic farms alive. For the first time in our history, humanity's survival would depend entirely on its ability to become a self-sustaining machine, a kind of technological ecosystem mimicking the sun's generosity. Food would be another story. Without photosynthesis, we'd have to grow crops under artificial light, powered by those same reactors. Vertical farms deep beneath the surface would sprout layers of lettuce, potatoes, algae, and fungi, the new pillars of cuisine. Forget fine dining. The future menu would be utilitarian and weird. Protein might come from lab-grown meat or insect farms, and water would be endlessly recycled from melting ice and condensed vapor. It would be a closed loop. every molecule counted, every calorie tracked. Waste would be a relic of the past, because in the void there's no room for wastefulness. But survival isn't just about biology, it's about psychology. A society that never sees the sky would have to find new ways to stay sane. Artificial environments could simulate day-night cycles to keep human circadian rhythms stable. Walls might be lined with projection panels showing digital skies or forests, reminders of a world that once existed above. Art and culture would shift, too. The mythologies of this new era would no longer celebrate the heavens. They'd glorify the depths. Songs would speak of warmth, of soil, of the comforting pulse of the reactors that kept them alive. In time, surface sunlight might become a legend, a golden myth whispered to children who'd never seen it. Communication would evolve as well. With most satellites gone and the surface too unstable, humanity might rely on underground fiber networks or radio links tunneled through caverns. The last global internet could become a literal one. Threads of light connecting pockets of survivors scattered across the continents. Knowledge would be shared constantly because ignorance would be lethal. Cooperation wouldn't just be noble, it would be mandatory. The days of nations and borders would end. In the darkness, there's no us versus them. There's only us versus extinction. Of course, some would dream bigger. Humanity has always had a stubborn streak of cosmic wanderlust. Even while Earth drifted through the void, there'd be those who'd refuse to stay buried. Perhaps teams of explorers would venture to the surface, clad in thermal suits, to mine frozen cities or salvage satellites. They'd walk across glaciers where oceans once rolled, under skies filled with faint auroras and stars brighter than anyone had ever seen. They'd return to the underground with stories, not of hope, but of perspective. It's beautiful out there, one might say quietly. Cold, but beautiful. Given enough time, we might even adapt biologically. Generations born underground could evolve new traits. Paler skin, larger eyes, maybe even enhanced resistance to radiation. Over millennia, they might diverge from the humans we know now. These descendants wouldn't be just survivors. They'd be inheritors of a new kind of Earth, one where darkness was home. Evolution would keep doing what it does best, finding a way. And if one day an alien probe passed close enough to detect heat signatures under the ice, they might pause in astonishment. Sensors would register faint patterns of light, rhythmic pulses deep within the crust, evidence of reactors still humming, networks still active. The aliens might send a transmission, not expecting an answer. But maybe, somewhere in those tunnels, a surviving radio operator, older than memory, surrounded by relics of a dead civilization, would catch the signal. Their message back would be simple, maybe even a little proud. We're still here. That's the thing about humanity. We've always been hitchhikers on someone else's cosmic bus, Earth's passengers, not its owners. And even if that bus goes off route, even if the stars outside turn cold and unfamiliar, we'd find a way to keep riding. We'd build, adapt, and keep our tiny lights burning beneath the frozen crust, stubbornly insisting that life isn't over until the universe itself says so. So yes, Maybe the aliens would look down and call us cosmic mold, still clinging to the cracks long after reason said we shouldn't. But that's fine. Mold, after all, is persistent. It spreads, it adapts, it survives. And in the great dark silence of the universe, that might be the most remarkable thing any species could do. Believe it or not, rogue planets might be common. Astronomers estimate there could be billions drifting through the galaxy, unanchored and unseen. Earth wouldn't be alone. It would be joining the galaxy's loneliest club. Some of those planets might even have subsurface oceans or hidden ecosystems. If life could exist on one of them, maybe Earth's new neighbors wouldn't be dead worlds, but survivors just like us. Maybe space is full of exiled planets swapping tales of the stars they once orbited. The thought of that is both comforting and eerie. We like to think of planets as loyal companions, faithfully circling their stars for eternity. But the truth is, the universe doesn't promise stability. Gravity's messy choreography regularly flings worlds out of their orbits, like cosmic toddlers throwing toys. During the chaotic early days of star formation, when young systems are still crowded and violent, planets jostle for position. The big ones bully the small ones, and every so often, one gets the ultimate punishment: exile. Out it goes, cast into the interstellar dark, stripped of sunlight, forgotten by the family it once knew. Astronomers have already detected a few of these wayward worlds, giant planets, some as massive as Jupiter, drifting alone between stars. We can't see them directly, not yet. They reveal themselves through subtle gravitational lensing, bending starlight as they pass in front of distant suns. Each discovery hints at something staggering. For every star in the Milky Way, there might be 2 or 3 planets wandering freely. That means our galaxy could be teeming with lost worlds, trillions of them moving silently through the void. Imagine them. A vast procession of invisible nomads, each one carrying its own story. Some are ancient veterans, flung out billions of years ago when their parent stars were still young. Others are recent exiles, still warm from the star they once orbited. Some might have moons, trapped companions sharing their endless drift. Others might have rings, glowing faintly with frozen dust. If you could somehow look at the galaxy from far above, you'd see these lonely travelers forming a vast, invisible web between the stars, a quiet diaspora of planets, endlessly crossing paths but never meeting. And yet, not all of them are dead. That's the exciting part. Astronomers suspect that even without a star, some rogue planets could still harbor life. Deep beneath their frozen crusts, geothermal heat might keep subsurface oceans liquid, just as it does on moons like Europa or Enceladus in our own solar system. These worlds could host ecosystems powered not by sunlight, but by chemistry. Bacteria feeding on minerals, strange organisms thriving in total darkness. Life, as we know, doesn't need much, just energy, a solvent, and a dash of stubbornness. And if there's one thing life excels at, it's refusing to give up. Now imagine Earth among them, our frozen blue marble joining this cosmic fraternity of wanderers. Perhaps it would drift through a region of the galaxy rich in interstellar dust, its icy surface occasionally catching light from distant stars. Every once in a while, it might pass near another rogue planet, each glowing faintly with its own geothermal warmth. There would be no way to communicate, of course, but the symbolism is irresistible. Worlds that once belonged to stars now finding quiet companionship in the dark. In a way, the idea of the Galactic Wanderers Club reframes loneliness itself. We often think of isolation as absence, a void where connection used to be. But what if the universe is full of isolated entities that still exist in silent solidarity? Planets, asteroids, comets, even civilizations, all drifting between anchors, all still part of the same grand story. Maybe that's what cosmic community really looks like. Not togetherness in space, but shared endurance through time. For scientists, rogue planets are also an astronomical jackpot. They could be laboratories of alien geology and chemistry, snapshots of what happens when a world is left to fend for itself. Some might have atmospheres that froze and collapsed, forming vast plains of solid nitrogen. Others might have retained thick hydrogen envelopes, turning them into warm, hidden worlds. Tiny stars without fusion, glowing faintly from within. If we could send probes to them, we might learn how planets evolve without starlight, how atmospheres behave in deep space, and maybe even how life adapts to cosmic exile. The challenge, of course, is finding them. Rogue planets don't reflect much light, and without the glow of a nearby star, they're almost invisible. The best hope lies in next-generation telescopes sensitive to infrared radiation, the faint warmth of planetary cores cooling in the dark. When we finally detect more of them, we'll be peering into a population of worlds that vastly outnumbers the ones we've been studying for centuries. For all our obsession with stars, it turns out the real universe might belong to the shadows between them. There's something profoundly poetic about that. Stars live loud and die young, but rogue planets endure. They drift for billions of years, outlasting the galaxies that birthed them, carrying their silence across the ages. Some may never be found, their existence known only to the gravitational ripples they leave behind. Others may one day be captured by new stars, beginning fresh orbits in unfamiliar skies. The universe is a restless place. Even loneliness isn't permanent. And maybe, just maybe, Earth won't wander forever either. Someday, a distant star's gravity could reach out, tugging us gently into a new family. We'd thaw, bloom briefly with warmth, and orbit once again. To the beings of that new system, we'd be just another planet among many. But deep beneath our surface, in the fossilized traces of cities and songs, would be the record of our first home. We'd carry the memory of our sun the way sailors once carried stories of the sea. If that happens, Earth will have graduated from the Galactic Wanderers Club, not as a victim of exile, but as a traveler reborn. And maybe, just maybe, some alien astronomer will look up at their night sky, spot our faint blue shimmer and wonder, where did that world come from? The answer would be simple and magnificent. From somewhere far away, from a place once filled with light, from a star that loved it dearly, and let it go. For billions of years, humans have wondered if we're alone. But if Earth ever became a rogue planet, we'd become someone else's mystery. Our fossils, ruins, and signals would whisper across light years. Maybe one day, a civilization light years away would finally detect us, pointing telescopes at our frozen sphere, asking the same questions we once asked about life beyond. The universe loves irony. It might let us become the answer to someone else's question. It's a strange thought. One day, the roles could reverse. We've always been the searchers, turning our telescopes outward, scanning for signs of other minds among the stars. We've built enormous radio dishes, sent out messages in bottles, golden records, coded pulses, mathematical greetings, hoping someone somewhere might notice. But someday, after our voices fade, we could become the very enigma we once chased. A quiet, wandering planet, wrapped in ice, floating through the dark, an object of speculation, study, and awe. Imagine the moment of discovery. Somewhere in another corner of the galaxy, a civilization advanced enough to map the night sky in microscopic detail notices something unusual. A faint object, colder than any star, reflecting just enough light to suggest atmosphere and structure. It moves not in orbit, but along a lonely, hyperbolic path. They focus their instruments, run spectral analyses, and find the first surprise. Oxygen, nitrogen, traces of carbon dioxide, frozen water. A combination too precise to be coincidence. They'd know immediately. They'd found a world that once breathed. Excitement would ripple through their culture the way ours did when we found the first exoplanet. Their scientists would gather, their philosophers would debate, their artists would paint visions of what this world might have looked like when it was alive. They'd call it something poetic in their language, perhaps the blue fossil, or the sleeping world. And somewhere in a quiet observatory, a researcher would stare at the faint light curve and whisper the question that has haunted every thinking species since time began. Did someone once live there? From their distance, they'd begin to decode our planet's story, piece by piece. They'd analyze the chemical signatures of our atmosphere, see the imbalance that life once maintained. They'd find traces of industrial activity, tiny residues of hydrocarbons, faint isotopic oddities that could only come from technology. To them, it would be like reading an ancient scroll. Fragments of text, parts missing, meaning obscured by time. The data would hint at intelligence, but never enough to be certain. Were we builders, dreamers, a biological experiment gone wrong? Then they might detect our artificial satellites, still orbiting, though long dead. Their radar scans would reveal symmetrical metallic shapes circling the frozen Earth. That would be the smoking gun. No natural process forms perfect circles in orbit. The realization would be electric. This was no ordinary planet. It was the grave of a civilization. And just like us, they'd begin to speculate. What were they like? Did they leave before it froze? Could they still exist somewhere else? Archaeology would become astrophysics. They'd study our electromagnetic echoes, tracing the oldest faint radio waves still traveling outward. Somewhere, at the edge of their detection limits, they might pick up a whisper, a fading human broadcast, distorted and ancient. Maybe it's a song, a speech, or even static from an old transmission tower. They'd amplify it, filter it, replay it over and over, trying to separate the noise from the meaning. One scientist might claim to hear patterns, music, rhythm, even laughter. It sounds emotional, they'd say, as if the signal carries feeling. That moment would change them. Because when another civilization finds evidence of us, they'll feel exactly what we've always felt when we look out at the stars. A mix of wonder and melancholy. The realization that intelligence may not last forever, but its traces can. That even in death, a world can speak. They might send out messages toward our frozen planet, hopeful transmissions that will never be heard. We see you, we understand. Our world would become their Rosetta Stone of lost intelligence, their own Are We Alone made tangible. Maybe they'd send robotic probes to study us up close. They'd descend through the thin, frozen air, mapping the continents, tracing the lines of ancient cities now buried under ice. They'd find our monuments, statues, bridges, towers, and speculate about their meaning. The Great Pyramids might be interpreted as astronomical observatories, Stonehenge as a form of clock, the Statue of Liberty as an idol of worship. The truth, as always, would be stranger and smaller than they imagine. And what would they make of our art? Suppose they discover a preserved mural or a digital archive, something still readable. Paintings, music, writing, our attempts to make sense of existence. They'd see color and pattern that meant nothing to them and everything to us. Perhaps they'd find humor in it. These beings seemed obsessed with circles and faces they'd note puzzling over emojis. Or maybe they'd feel something deeper, recognizing in our work the same spark that drives their own creativity, a defiance of the void. It's tempting to think of such a discovery as validation, that we mattered because someone else noticed. But in truth, it's not about recognition. It's about continuity. The universe is vast enough that everything eventually becomes someone else's mystery. Stars become nebulae, planets become fossils, civilizations become data points. We are all, in time, reduced to questions. And that's the great cosmic irony. We've spent millennia trying to find proof that we're not alone, never realizing that someday we will be found, just not as explorers, but as echoes. Maybe that's the universe's quiet joke on every intelligent species. You start by asking if anyone's out there, and end by becoming the evidence that someone once was. So when the aliens finally chart our frozen orbit and debate our origins, they won't be seeing ghosts. They'll be seeing themselves, reflected across time. Because curiosity, it seems, is the one thing that never dies. And perhaps, as their telescopes turn back toward the stars, one of them will whisper almost reverently, "Whoever they were, they wondered too." And in that moment, across the endless silence between stars, our question will finally find its answer, not in words, but in understanding. Eventually, Earth would drift so far that even the Milky Way would fade into the background. But our story wouldn't be lost. Every trace of light, every particle, every frozen artifact would still exist somewhere in the cosmic record. Maybe that's the quiet beauty of it. Even if our world ends, the universe keeps the receipts. In the grand cosmic timeline, Earth might just be a brief flicker, but one that burned bright enough to be noticed. After all, even if we became someone else's 3i-ATLAS, it means we once mattered enough to be found. It's hard to think of permanence in a universe built on decay. Stars collapse, galaxies collide, atoms fall apart. Everything that exists is a temporary arrangement of energy pretending to be solid. And yet, for all its impermanence, the cosmos has an extraordinary memory. It doesn't forget, it transforms. Matter doesn't vanish, it changes form. Energy doesn't die, it diffuses. Every photon that has ever left Earth is still out there, racing endlessly through the void. Every word spoken into the air, every spark of lightning, every candle ever lit. All of it contributed a tiny pulse of energy to the great electromagnetic ocean that is space. If you could stand at some impossible vantage point billions of light years away and look back through time, you could, in principle, see us as we were. You'd watch our sun glowing yellow and warm, our planet turning in delicate balance, clouds drifting across continents. You might even catch the glint of city lights before the freeze. Tiny, artificial constellations stitched into the night. Because that's how light works. It carries the past forward. Even as Earth becomes a relic, its history continues outward, encoded in photons streaming forever. This cosmic memory extends beyond light. Dust and atoms, those quiet record keepers, also tell our story. Every element forged in our planet's core will one day scatter. The iron in our skyscrapers, the calcium in our bones, the carbon in our forests, all will be recycled into new cosmic projects. Over unimaginable spans of time, the frozen Earth could collide with other drifting debris, its fragments pulled into the gravity wells of new stars and planets. Our atoms could end up inside another world's soil, or another civilization's bloodstream. The universe is, in that sense, an endless recycler. Nothing is truly lost. It's simply repurposed. Someday, the raw materials of Earth might help another planet bloom. That idea, that memory isn't erased but redistributed, is quietly comforting. It means that our existence leaves ripples far beyond what we'll ever see. Even when everything human vanishes, we'll still be there, just rearranged. The molecules that once made up Shakespeare might one day drift through a nebula and condense into the body of an alien poet. The iron from a human heart might sit at the center of a new world, its magnetic field guiding alien compasses. The carbon from an ancient forest could become the diamond core of a distant moon. It's reincarnation, not of spirit, but of matter. Eventually, though, even the galaxy itself will change. In tens of billions of years, the Milky Way will merge with Andromeda, creating a colossal, elliptical galaxy, its stars blended like spilled ink. Earth, if it still exists by then, will be a grain of ice floating through the merged expanse. And when the last stars burn out, when the cosmos grows cold and dark, our planet's atoms will still hum faintly with the residual energy of their creation. The end won't be an explosion, it will be a whisper. But even whispers travel. The universe, in its quiet way, is the best historian imaginable. It records not with ink or memory, but with existence itself. Every cause leaves an effect, every action a trace. When a star shines, it alters the cosmic background. When a planet forms, it warps space just slightly. And when a civilization like ours builds, loves, laughs, and vanishes, it leaves behind an imprint no entropy can fully erase. Maybe that's what immortality really is. Not endless life, but unending influence. Think about it. Every telescope we've ever pointed skyward has been looking into history. The light from a distant galaxy is millions of years old. The glow from a dying star might be a message from an era when dinosaurs still walked our world. So, if the universe remembers others in that way, why wouldn't it remember us? Somewhere, billions of years from now, a photon bouncing off a rusted satellite or frozen city will finally reach another star system. It will brush against the sensors of an alien observatory, a faint, almost imperceptible flicker. And in that flicker, an entire civilization will be preserved. Perhaps those aliens will never know what they're seeing. Perhaps they'll record the signal, label it as unexplained anomaly, and move on. But the fact that the light exists, that it travels, that it persists, is enough. It means that somewhere, deep in the code of the cosmos, our story remains. Not as a book on a shelf, but as a pattern written into the movement of energy itself. When we imagine endings, we often think of silence. But the truth is, the universe never truly falls silent. It hums eternally, filled with the faint afterglow of everything that has ever happened. The cosmic microwave background, the oldest light we can detect, is itself a memory of the universe's own birth. If the cosmos can remember its beginning, it can remember us too. So yes, one day Earth will be gone. The oceans will evaporate, the mountains will crumble, and the last trace of civilization will dissolve into dust. But nothing that ever existed disappears completely. The universe has already archived us, in starlight, in atoms, in gravity's subtle fingerprints. And maybe, at the very end, when the last particles drift apart and the last black hole exhales its final whisper of radiation, that memory will still shimmer faintly in the dark. The story of a small blue planet that once existed, once tried, once wondered. A brief flicker in eternity, yes, but a bright one. A spark that said, "We were here." And in the language of the cosmos, that's all that's ever needed to be remembered.